All right, everyone. Well, thank you for joining us tonight. So just a little bit about the program first. So I'm Dr. Billy Teets, and I'm the director here at the Vanderbilt Dyer Observatory. So I want to thank every one of you all for joining us tonight. This is a huge turnout. We're so thrilled about this. And thankfully, the clouds have moved away for us here in Brentwood, which is just south of Nashville. And we've got a pretty good view of Jupiter and Saturn right now. And so tonight, what we'll be doing, I'm going to try my best to monitor our chat and answer as many questions as I can. But I just thought that we would at least have the view going for as long as we possibly can, which should be at least until 6 o'clock Central Time. And we'll just try to answer as many questions as we can. Have a good time. I'll play around a little bit with the exposure of the view so that we can pull out some other images, specifically things like the moons of Jupiter and maybe one of Saturn. So one thing you'll notice is that Saturn and Jupiter are not incredibly sharp tonight. Unfortunately, the seeing, as we call it, is not too good this evening. So when we talk about seeing, all we're talking about is how still is the atmosphere. So if we were to look at an object, how sharp would it actually be? So tonight the atmosphere, because we've got a front going through, is really moving quite a bit. So as the light from Jupiter and Saturn is coming in through the atmosphere and trying to get to our telescopes and to our eyes, it's having a very difficult time, and it's getting bounced around quite a bit. And that's what's causing this fuzziness. In fact, if you watch Jupiter and Saturn, especially in a telescope tonight, if you're in the Nashville area, you'll see that it kind of looks like you're looking through basically a swimming pool. Like you're looking at the bottom of a pool and you're seeing the images of Jupiter and Saturn kind of getting really wavy and whatnot. And that's an effect of our atmosphere. So of course, they're not actually doing that, but we just say that the seeing for the area is bad. But as Brian Smokler, who is our helper tonight at Vanderbilt University News and Communications, he's making sure that our broadcast gets out to all of you. As he pointed out, the seeing is likely going to increase as we get a little bit later into the evening. It's not going to be a huge difference. Cross our fingers it will be, but we might see a little bit of an improvement as the wind's dying down. Earlier today was really blowing, but we should hopefully see a little bit of improvement in the view and might be able to see a little bit more of the features of these planets. So I'm going to pause for just a second. Sorry for the delay, folks. I had a little technical issue downstairs, had to take care of. So we're back. So I'm seeing a lot of comments about if the view can be cleared up a little bit. Unfortunately, it is because of the atmospheric conditions here at the observatory. It might get a little bit clearer as we go on, but unfortunately, things are a little bit fuzzy right now. So what I'm going to do, which by the way, one thing I want to definitely encourage everyone, if you've got clear skies tonight and you're watching this, please go out and look at the conjunction with your own eyes. If you've got a pair of binoculars, that'll give you an even better view. If you've got even a small telescope, that will give you a really nice view of Saturn's rings, the banding on Jupiter, and some of the moons of the planets as well. All right, so there we go. Sorry about that. Looks like we had an issue with the sharing there. All right, so I apologize for that. I didn't realize that the screen sharing had paused for a moment. So you should now be able to get a little bit better view of these planets. So obviously we've got Jupiter at the bottom, Saturn up towards the top. And I'm going to bring up the exposure just a little bit here. Now, the planets themselves are going to look, they're going to get brighter and they're going to get more blob. I apologize for that. I didn't realize that the screen sharing had paused for a moment. So you should now be able. Okay. Let's see here. Sorry, I had one other little technical detail there. So I'm going to bring up the exposure just a little bit more, bring up the gain. So Jupiter looks like it's getting really bright. Saturn looks like it's getting really bright. But the reason I'm doing this is because now we can see a few other objects that we weren't seeing before. So now we've got Jupiter's 4 large moons, which are known as the Galilean moons. And you can see Saturn here. There's an object right up here that is Saturn's largest moon, Titan. It's actually the second largest moon in the solar system. The largest is actually Ganymede, which is, have to look back up which one of these 3 it is, or one of these 4 it is. But Ganymede is actually the largest moon in the entire solar system. It's bigger than the planet Mercury. So 3 of these large moons, Io, Ganymede, and Callisto, are larger than our own moon. Europa, the smallest of the 4, is a little bit smaller than our moon. Over here, you'll also see that we've got this little object here that is actually just a background star, as is this one over here. I did see that some folks had asked, or I saw one person ask if they were in Ireland, would they be able to see that? Yes, basically, most people around the globe are going to be able to see um, this conjunction up to a certain point. If you get up to about where the Arctic Circle is, unfortunately, the planets just never really get up that very high this year for this conjunction, and really wouldn't be able to see them from really far up north. But pretty much everybody else on the globe is able to see them. Now, the closer you are to the equator, the longer that you would be able to see these. And it's not by a large amount, but you'd have a little bit longer time than, say, what folks here in Nashville would be able to see. Let's see. Another really nice thing about looking at Jupiter, if you observe these moons tonight, and then you look at them tomorrow night, you'll notice that they're in a different configuration. The closest in of those 4 moons, which is Io, it only takes about 1.8 days to orbit Jupiter. Jupiter's got a very large gravitational field because of its large mass. If you took all of the planets other than Jupiter, so Saturn, Uranus, Neptune, all the rocky planets, smushed them together and made another planet, they still wouldn't be as massive as Jupiter. In fact, wouldn't really even be about half as massive as Jupiter. So Jupiter is really the big guy planet-wise in our solar system. But then our sun really dominates in that it's about 1,000 times as massive as Jupiter. So it contains over 99% of the entire solar system's mass. Now I'm going to bring the exposure back down so we can see a little bit more detail here. You'll start to see the gap between Saturn and the rings of the planet. And if I bring it down a little bit more here, Saturn's going to get pretty faint. You'll start to see, it's kind of hard to see tonight because of the atmosphere, but you'll start to see some banding on Jupiter. So that banding is known as, the dark areas are known as the belts, and the lighter areas are known as the zones. So they're not the rings of Jupiter. Jupiter does have rings, but this banding is a result of different layers of the atmosphere. So sometimes one of those belts may disappear, as we saw a few years ago, and then it'll come back a little bit later on. So Jupiter's a very dynamic world. It's constantly undergoing changes in its atmosphere. And on a really good night, you can see some of those features in the atmosphere, like the Great Red Spot. So a little bit about this conjunction. Bring our exposure up just a little bit more here so we can see Saturn a little bit better. So this conjunction, as I'm sure you've been reading, is it's a very rare conjunction. And when we talk about conjunctions, what we mean is that 2 objects will appear to get close to one another in the sky. That might be 2 planets, or even 3 planets at times. It might be a planet and a moon, or in our moon, I should say. But that just means that they're getting close together from our viewpoint. In reality, these planets are still somewhere between 400 and 500 million miles from each other. So they're still incredibly far away from each other. But from our viewpoint here on the Earth, it looks like they're right next to one another in the sky. So Jupiter and Saturn, they meet up about every 20 years. It's actually something like 19.8 years, but roughly 20 years. So back in 2000, we had another conjunction, but the 2 planets didn't get this close together in our sky. They were about a little over 2 full moon widths apart. So to give you an idea of how big that is, if you can't see the moon tonight, take your index finger and hold it out at arm's length from you, and close one eye and see how big it is on the sky, or how wide your finger is on the sky. How much sky does your fingertip cover? Believe it or not, that's about 2 full moon widths. Okay, so that's about, so if you imagine Jupiter being on one side of your finger and Saturn being on the other side, that's about how close they were in 2000. This year, because of the way the planet's orbits are inclined, the way our orbit is inclined, and where we all are in our orbits, they appear to get much closer together in our sky. So in 2040 and 2060, we will also have conjunctions, but they won't appear nearly as confined as we see tonight. They'll be again about 2 full moon widths, which is about 1 degree on the sky. But in 2080, we will have another one of these conjunctions. It will be another one of these very rare, very close conjunctions. So in 2080, instead of looking in the evening sky, if you get up early in the morning, it's March 15th actually, of 2080, you'll be able to see Jupiter and Saturn really close together just like this in the early morning sky. And then it's going to be, I forget exactly how many years till we have the next really close conjunction. So for a lot of people, this will be a once in a lifetime event. So again, if you can go out and see this with your own eyes, please do go out and check it out because tomorrow night, even if you have clear skies, they're not going to appear this close together, but you'll probably be able to get both of them still in the field of view of a telescope, definitely binoculars. But over the next, or as time progresses, they will appear to move farther and farther apart from one another. So I'm going to see if we've got any questions here. Okay, so let's see, let me go down here. Let's see, I'm just trying to see which questions are coming up here. I think I saw something about which app that I'm using to do the view here. So this is actually a control software for the camera that we're using on our telescope. Actually, let me move out of the way here. So it's a little bit hard to see here. In fact, I might have to move to the other side. Turn up our light just a little bit. I'm not going to be able to get the light up much more. But behind me is a 16-inch telescope. It's called an astrograph. It's a telescope that's not really made for looking through with your eye. It's made more for photographic equipment. Oops, I lost my light. Here we go. It's made for more for photography. It has a very wide field of view. And that's the reason we chose this telescope tonight for viewing this conjunction. Because the camera that we're using on the back of it, which is, it's made by a company called ZWO, with that wide field of view, we'd be able to get both of these planets in here at the same time. All right, so to switch topics just a little bit, if you go out tonight, you'll see that we have a first quarter moon. So Jupiter and Saturn are low in the southwestern sky. The moon's getting pretty high up in the sky now, and we're basically seeing half of it. Sorry, I don't know why my light keeps going out here. I'm going to turn it down just a bit. But if you happen to be over, say, in the western United States, you have an opportunity tonight to, if you have a telescope anyway, to see a feature on the moon called the Lunar X. It's actually it's a feature that is visible only for a few hours every lunar month. As the lighting from the sun gets just right on the moon and illuminates some crater walls, there are 3 craters right next to one another. In fact, their walls meet, so that when the sun shines on them just right, and again, it's just for a few hours each month, it looks like their walls make out this nice letter X. And you don't really have to kind of squint and tilt your head just right to try to make out an X. It's very, very apparent. So for those of us here on the eastern side of the United States, it's not quite the right timing. The moon is pretty much going to be setting when the Lunar X becomes visible, but it happens every month, and you just have to be in the right spot or kind of the right quarter of the globe to be able to see it for those few hours. So Definitely look it up and check it out. It's really neat to see with your own eyes. So there was a question here, where are all the stars? So there are lots of stars in this view, but the problem is because the planets appear so bright in this view, we have to bring the exposure down so that we don't overexpose the planets and make them these huge bright blobs. So if I go back, and we did this a little earlier, but I'm going to show one more time here. If we go back and we bring up the exposure, I'm going to bring it up to about right here. You'll start to see the moons of Jupiter again, and bring up some gain here. There we go. You'll see this object over here, that is a background star, as is this one here. So there are a few stars that are bright enough that if we do bring up the exposure enough, we can actually see some of those stars. It's kind of like the questions about, why can't you see stars in the pictures that they took from the moon? And that's because the moon's surface is so incredibly bright that you had to have incredibly short exposure in order to see surface details. And so the stars were not bright enough to be seen in those views. So I'm going to bring this down just a bit here. I'm going to have to move the dome. I'll be right back, and we'll try to get to some questions here. All right, everybody, I'm back. So again, for everybody that has joined us tonight, can't thank you enough for this. I've been so excited about doing this conjunction, keeping my fingers crossed we'd have good weather here in Nashville, and thankfully we have. So I'm gonna go back through a few things that I'd spoken about earlier. If you have been here at the start of the program, you'll probably have heard this before, but this is especially for those who have just joined us maybe in the last few minutes or so. So again, we're looking at obviously Jupiter and Saturn here. I'll bring up the exposure just a little bit more to where you can see some of the other things that are actually visible in our field of view. We've got Jupiter down at the bottom, and you can see 4 large moons here. One is about to disappear in front of the disk of Jupiter there. You can definitely see the rings of Saturn. You will notice that the view is kind of fuzzy tonight, and it's actually 2 factors that are contributing to that. The first is we've had a front that has been passing through the Nashville area. So today, if you were outside, you would definitely have noticed the wind. So that means the atmosphere is very turbulent, and even though the atmosphere is clear, it can cause light to bend quite a bit and kind of bounce around. So that's why it looks like Jupiter and Saturn are like you're looking at them through at the bottom of a swimming pool. And it's just because the atmosphere is moving above us so much right now. The other thing is that Jupiter and Saturn are constantly getting lower and lower in the sky. So everything in the sky is rising and setting. And so these guys are about an hour from setting. So they're getting pretty low in the sky. So the density of the atmosphere increases the closer you are to the surface of the Earth. So as we're looking across the horizon to objects that are really low in the sky, not only are we looking through the densest part of Earth's atmosphere, but we're looking through a lot of it. Okay, and so with all of that atmosphere, that's going to cause the light waves to be bounced around quite a bit, and that's why they appear to move. When you watch stars that get closer to the horizon, you will see them twinkling like crazy. And that is an effect of our atmosphere. Stars don't actually twinkle. So as they're getting lower and lower, they're probably going to get a little bit fuzzier and fuzzier, but unfortunately that's not really, there's nothing we can really do about that. But thankfully, we have clear skies and we can see them tonight. Again, if you have not gone out and looked at these guys with your own eyes tonight, please get up and do that right now. We're not going to have them up for much longer, and it's nothing like actually seeing it with your own eyes. I did step out of the telescope dome here just a little while ago, and they are gorgeous together now that it's getting dark enough. Really, really a beautiful sight. And again, this is not this particular type of conjunction where we have Jupiter and Saturn so close to one another. That's not going to happen for another 60 years. We'll have conjunctions every 20 years of Jupiter and Saturn, but they won't get this close together again for another 60 years. So definitely take advantage of this if you can. And if you miss it tonight, maybe it's cloudy in your area, if you go out tomorrow night, they won't be quite as close together. They will already have started to move apart from one another, but they'll still be pretty darn close together. And they'll definitely still be closer together than we'll see in 2040 or 2060, okay? So I'm going to try to adjust focus just a tad here to make sure we're getting the best view that we can. Unfortunately, it's just really hard to pull out any more focus. Maybe a tad bit better there, but that may be wishful thinking. So obviously we have Saturn's rings here. Let me hold on, I'm just checking my chat here. The question was, could we zoom out? No, I can't zoom out anymore. So this field of view, this is actually a fairly wide field of view. This is about 1/5 of a full moon diameter. So full moon is about a ½ degree wide. So what we're looking at here, the separation here, this is about 1/10 of a degree, okay? So the next time we have a conjunction of Jupiter and Saturn, which will be in 2040, they will be separated by about 10 times the separation. So What's really cool about this particular conjunction is not only is it really close, but you can see both of these planets in the same field of view of a telescope like we're doing tonight. And that is very, very rare. Okay, so again, these planets aren't actually physically close together. It's just our viewpoint here makes them look like they're right next to one another. If you were to go to the planet Mars, Jupiter and Saturn wouldn't look like they're this close together at all. Okay, so it just happens to be our viewpoint from the Earth here. So Saturn's rings, they would fill, if you put them next to the Earth and Moon, they would fill up about 3/4 of the distance from here to the Moon. So they're about 180,000 miles wide, but they're less than a mile thick. They are incredibly thin for their width. So it's kind of like if you wanted to make a scale model of the rings, if you made the rings the size of a football stadium, the rings would be about the thickness of a sheet of paper. Okay, they are super, super thin. Now this year, they appear to be somewhat tilted towards us, so we can kind of see over the top of them a little bit. But in the coming years, every year we will see them a little less tilted, okay? And then forget what year it is. I think we have about 5 years or so. But we will have the rings go edge on for about a day or two. When they go perfectly edge on, we can't see them at all. Not even the Hubble Space Telescope can see them because, again, they're so incredibly thin. And they're typically about 1 billion miles from us. Okay? So Saturn is it's about 10 times the Earth-Sun distance. So seeing something that's a little bit less than a mile wide from a distance of about 1 billion miles is incredibly hard to see. Let's see. So again, I mentioned earlier, we've got the moons of Jupiter here. We're only looking at 4 of them. Let me adjust my view just a bit here. I'm going to move them over. So I'm just moving the telescope ever so slightly, just to kind of refocus or recenter them. But there you can see them. One's right next to Jupiter. I'll bring the exposure down just a bit here. We'll try to pick out a little bit of the features of Jupiter. It's kind of hard to see, again, because we've got a lot of atmospheric turbulence. We've got the planets getting very low, but you can just barely make out a band on Jupiter right there. So that's not the ring of Jupiter. That's actually an atmospheric band. Okay, the rings of Jupiter you can't really see from the Earth. They are so small or so thin and minuscule compared to Saturn's rings that they weren't actually discovered until we had the Voyager missions arrive at Jupiter in the 70s, and they actually went behind Jupiter to where Jupiter blocked out the sun's light, and the rings appeared to glow because they were scattering sunlight. So they are very, very thin, or are very, very diminutive, I guess you could say, as compared to the rings of Saturn. So Saturn definitely has the best ring system by far. It looks like, if you could take the rings of Saturn and make an object out of them, that it would make a pretty large object. But actually, it would make an object smaller than our own moon. So the rings are composed mostly of ice. It's got some dust in them as well, but these are particles that are maybe sand grain size to some objects that may be as large as a car or maybe a very small house. But it's thought that maybe these rings formed from 2 small moons that collided and broke apart, and all that debris went into orbit around Saturn. Or it could have been a moon moved in a little bit too close to Saturn and got within what's known as the Roche limit, which is where the gravity of Saturn is then strong enough, because you're close enough to the planet, that the moon would actually get shredded. Okay, so either of those 2 theories fit pretty well. The jury's still out on kind of which one works the best there. Let's see. So here's so Brian is trying to help me go through some of the questions here. So I really appreciate that, Brian. Do other planets have conjunctions? Yes. And so earlier this year, I think it was October, we had a really nice conjunction of Mars and the Moon. And so the reason that these objects appear to get close to one another is that if you actually look at how the planets orbit the sun, we don't have, let's say if my fist is the sun, we don't have one planet going around this way, then one planet going like this. They all orbit in roughly the same plane. Now, all those planes, all those orbital planes are tilted a little bit with respect to one another. So the planets don't follow exactly the same path through the sky, but they follow roughly the same path through the sky. So you'll always see the planets running through a particular area of the sky. And that's the area that contains an imaginary line called the ecliptic. So the ecliptic is the path of the sun through our sky. And because we are one of those planets that are orbiting the sun, and we're orbiting roughly the same plane as those other planets, we will see the planets basically follow the same path as the sun through the sky, which means that when we see them kind of meet up in our sky, they're often not too terribly far from one another. We sometimes have closer conjunctions like we have tonight. We'll have conjunctions where we have maybe 3 objects that are fairly close together, but not quite this close together. So we can have lots of different types of conjunctions, especially with the moon, because it's a little bit larger, and it also orbits in roughly the same plane as the planets. Its orbit is tilted by about 5 degrees to that ecliptic line. So what would the rings of Saturn look like if you could stand on Saturn? So if you could stand on Saturn, the rings would show up depending on your field of view, or excuse me, not your field of view, but your location on the planet. You would think, well, if the rings are going around the equator of the planet, then maybe I should stand at the equator and I could get a grand view of them. Actually, that'd be one of the worst views, again, because since those rings do orbit around the equator and they're so incredibly thin, you'd actually have a hard time making them out because it'd be like this thin little line going through the sky. But if you went up to, let's say, the northern hemisphere a little bit, or down into the southern hemisphere, depending on where the sun is, you would actually see a really nice ring system going through the sky. One program I would definitely recommend that you download and try out is called Stellarium, Stellarium. You can go to stellarium.org. And you can download this program for free. But one of the really fun things is you can actually go to one of these planets. Now, typically it won't show you the surface of the planet, but it'll basically change the sky so that you see what it would be like, what the sky would look like on that planet. So you could, for example, go to Saturn. Obviously, you can't stand on Saturn. It's a gas giant planet. But if you could stand on Saturn, then you'd be able to see the rings depending on where you are. And this program will actually simulate that. And it's really interesting to check that out. There are even some YouTube videos where people have simulated this. So they would have a pretty impressive display if you were in the right hemisphere. Let's see. How big of a slice of the sky are you showing in the current telescope view? So we are looking at an area that is about, let's see, this entire field of view here. So right now, the separation between Jupiter and Saturn is about 6 arc minutes. That's 1/10 of a degree. Another way to say it is that is 1/5 of the full moon diameter. Okay, so if this is 6 arc minutes, then this area here would be maybe about 10 arc minutes in diameter. So we would be looking at about 1/3 of the width of the full moon vertically, and about a little less than 2/3 of the full moon width horizontally. So believe it or not, if you take your pinky nail, so if you take your little finger and you hold it out at arm's length, close one eye, see how much of the sky your pinky nail covers, your pinky nail is actually just a little bit larger than the moon, or it might be right around the size of the moon, but typically it's a little bit larger. You got a clear sky, go out tonight, hold your finger up at arm's length and make it look like it's right next to the moon. So you'd be looking at an area that is actually much smaller than your pinky nail. Let's see. So would an observer on Saturn see a similar sight towards Earth? Very good question. So we're basically, it's almost like the Earth, Jupiter, and Saturn are almost in a straight line with one another. That's why we see these two planets so close together. If we were on Saturn looking back towards the Earth, well, there's a couple things we have to take into account. First of all, because Saturn orbits outside of our orbit, we would be looking towards the sun, which means that a lot of the surface of the Earth and Jupiter from Saturn's view would not be lit up. So it'd be a little bit difficult to see those planets. But if you could easily make them out, then if you were standing on Saturn, Jupiter and the Earth would look like they were very close together in Saturn's sky. Now, if you were on Jupiter and look for Saturn and the Earth, well, you'd have a little bit hard time seeing Earth because, again, Earth orbits inside of Jupiter's orbit. But if you could figure out where exactly Earth is, Saturn would be pretty much exactly on the direct opposite side of the sky. Okay. Can we see this without a telescope? Yes, please. If you have a clear sky, please go out now and try to check this out. It's cool to be able to see the planets through a telescope like this. And again, our view isn't too terribly good tonight, but I'm glad we have a view anyway. But go out and check them out because Saturn will look like a fainter star right next to a brighter star, which is Jupiter. But again, these aren't stars, these are planets. But the view, especially in the fading glow of sunset, is absolutely gorgeous. I got to go out and see it just a little bit ago, and it's really, really beautiful. So please take the time, go out there and check it out. Again, you won't be able to see this type of conjunction for another 60 years. I mean, when I say that, I mean this close of a conjunction. How many light years away is Jupiter? Maybe a few light minutes. So good question. So Jupiter right now is, if we were at our closest to one another, which we're not at our closest, but we're about 5 to 6 Earth-Sun distances from Jupiter. And that means that every Earth-Sun distance, it takes light about 8.5 minutes to travel. So the light that we're seeing from Jupiter right now, and I don't know the exact distance Jupiter is at this moment from us, it's going to be about 6 Earth-Sun distances or 6 astronomical units. That means that the light that we're seeing reflected off of Jupiter right now left about an hour ago. And for Saturn, it's going to be even farther than that. It's going to be about double that. Okay. Let's see. So is that Mars on the other side of the moon? Make sure that I'm giving the correct answer. Let me pop out right quick and check. So yes, the other bright object, so you got Jupiter and Saturn in the sky, then you got the moon, then you got this other bright object. Notice it has a very orange color to it. That is the planet Mars. So Mars reached what we call opposition a couple of months ago, and that's where we basically came in between it and the sun, and it was one of our best views for a while. We're gradually moving away from it, so it's going to gradually get smaller and smaller and dimmer in our sky. But that is Mars indeed. Are the planets interacting at all? They really are not interacting at all. They look very close to one another in our sky, but again, they are still about 400 to 500 million miles from one another. So they are incredibly far apart. It's just a viewing perspective that we have tonight that makes them look like they're really close together. Let's see. Do we feel a gravity change on Earth? We really, really do not. So that was one thing that I was wondering about when the conjunction really started to get a lot of media coverage, social media coverage. Is, we've got this conjunction that only happens, once in a very long time. And it's happening on the solstice. Does that mean the end of the world? Absolutely not. So the gravitational effects from Jupiter and Saturn are much, much, much smaller than the gravitational effects of our moon. Okay. In fact, the tidal effects, the way the moon's gravity interacts with the Earth, is about twice as strong as the gravitational influence, or the tidal influence, I should say, of the sun on the Earth. Now, we are in orbit around the sun because the sun has the most mass. But when you look at, say, the tides on the Earth, when you see the rise and fall of the ocean over time, that's due to the gravitational influences of the moon and the sun. And even though the moon is much smaller in mass compared to the sun and thus has less gravitational pull on us, due to its much closer proximity, its tidal effect on us, its influence on the tides, is actually about twice that of the sun. And so for Jupiter and Saturn, they really aren't affecting us at all. Okay. Let's see. Do we know if famous astronomers like Galileo or Copernicus ever saw a conjunction like this? That's a really good question. I honestly don't know. There are a lot of tables of conjunctions online that you might look up and see when they happen, and then look at the lifetimes of Galileo and Copernicus. But for example, each of them easily lived past the age of 20, and given that conjunctions of Jupiter and Saturn occur every 20 years, they would have seen conjunctions of Jupiter and Saturn. Maybe not necessarily like this, but nevertheless, they would see Jupiter and Saturn get at a close point in the sky. It might not have been very, very close, but they would have seen conjunctions. Let's see. Why does Jupiter appear so much brighter than Saturn? Very good question. The main reason is because Jupiter, or two main reasons. Jupiter is a little bit larger than Saturn, and it's also much closer. It's about twice as close. It's got very reflective cloud tops. So does Saturn, but that proximity to us really helps out the brightness of Jupiter. If you ever see the planet Venus, if you get up early morning right now, you'll see Venus in the early morning sky. It actually outshines Jupiter because it's got very reflective cloud tops, but it's also much closer than Jupiter is. So even though it's much smaller, that difference in distance really helps out Venus. So will they drift closer together overnight? If I remember correctly, I think we're basically at the maximum, or the minimum distance that they will be from one another. So they might inch ever so slightly closer, or to get to that exact closest point, but they're not, say, going to get twice as close as what we're seeing now. Okay. Is Pluto behind them in the distance? Pluto is actually over in that part of the sky, but it's not going to be in the same field of view. That would be really neat if it was, because even though we wouldn't be able to see Pluto because it's so faint and we're trying to see brighter Jupiter and Saturn, it would be really neat to think that it is actually in the same field of view. That would be a triple conjunction of those three objects, but unfortunately, it's not in that same field of view. But again, it's in that same general area in the sky. Let's see, what type of scope are we using? So tonight we are using a 16-inch astrograph. So it's a reflecting telescope, and it's on a robotic mount. And the reason we're using that one and not our even bigger telescope is that, for one thing, this telescope behind me has a much wider field of view, so we could actually see these two planets. And the other thing is we've got some trees that would block our bigger Seyfert telescope before this telescope gets blocked. Let's see. So why did this happen 800 years ago, but now 60? So we had a very similar conjunction in year 1226, which could be seen pretty easily. Then we had one in 1623, which was next to impossible to see because the two planets set soon after the sun did, so it made them really hard to see. But now we have this one, and now 60 years from now, we're going to have another one of these. So it all has to do, you could think of it as like a resonance. So if we had two objects if it was just saying, okay, well, how long will it take Jupiter to get back into the same part of the sky? We're not considering Saturn. We just want to follow Jupiter. Jupiter would get back to the same part of the sky at a very regular interval. However, we've got now two planets that are orbiting at different rates. And so there are, it's really interesting when you start talking about how long it takes from our perspective, each of these to actually reach the same point in the sky. It's not at an extremely regular interval where we see these very, very close conjunctions. Again, we're going to have a regular conjunction every 20 years, but we have these very, very rare close conjunctions at somewhat irregular intervals. A good example of that is a transit of the planet Venus. And so when I say transit, what I mean is that Venus is passing in front of the sun. So this happened back in 2004. I was lucky enough to get to see that one, and it also happened in the year 2012. But we'll have another 125, something like 120 years before we have another pair of those transits. So you may say, well, why wouldn't we have a transit like every 8 years or one every 120 years? Why do we have the pair and then have to wait for this large gap of time? It just really has to do with, we're not talking about the motion of one object, in this case Venus, but we're talking about the motion of another object, which is where the sun also is. And so when we see, for example, the first transit of Venus, we'll see it kind of go across the bottom of the sun. And then the next transit, we'll actually see it go across the top of the sun. And then another 8 years after that, when we might have another transit, it turns out that Venus actually goes a little bit too high or a little bit too low in order to cross in front of the sun from our viewpoint. So we won't see a transit then. So it's kind of the same thing here. In fact, the next one of these really close conjunctions, so you see we've got Jupiter at the bottom here and we've got Saturn at the top. And the 2080 conjunction, not only will these two planets be pretty much this exact same distance from one another in our sky, but they'll be flipped. So Jupiter would then be up here and Saturn would be down here at the bottom. So it just ends up dealing with the mathematics of how these orbits actually work. And it really just deals with the timings of them all. Let me check to make sure our telescope needs the dome to move. Be right back. All righty. So I just took a look at where Jupiter and Saturn are in our sky, and you probably noticed that Saturn is getting a little bit dimmer, so is Jupiter, and they're also getting even fuzzier and more wobbly, if you will. And that's because they are really starting to get low now. In fact, it's not going to be too long before we're going to have to probably stop because they're going to be getting too low. They're really going to start getting in the trees, and then the view becomes really bad and we can't really see much at all. So again, I want to reemphasize, if you haven't gone out and looked at these guys, if you can, please do go out and just look with your eye. Saturn is really close to Jupiter. At first you may have a hard time seeing it. It took me a second to really spot it in my eyes to adjust, but it was really incredible just to see it with my naked eye. And again, they're not going to be the same distance from one another tomorrow night. This is the night of their closest approach. This is technically the night of the main conjunction. So tomorrow night they will appear a little bit farther apart. If you've got a telescope at home and you've got cloudy skies tonight but clear skies tomorrow night, then you could take your telescope out and you'll likely still be able to get them in the same field of view. But if you wait, let's say a week, then they will have moved far enough that it'll be very difficult to get them in the same field of view. Let's see. Do we have images of Saturn and Jupiter that maybe we could talk just a little bit about? You know what? I'd say let's try to follow these just for a few more minutes. And one thing I can definitely do is bring up that program that I had mentioned earlier, Stellarium. And so we can take a look at Jupiter and Saturn then, and we'll zoom in on them, kind of zoom in on the moons that we were seeing, and talk just a little bit about those. So I'm going to try to bring up the exposure just a bit more, see if we can still pick out some of those moons. All right, so now our planet's overexposed, but if you joined us earlier, you noticed that there were 4 moons, but now we only see 3. And that's because one of those moons is believe that it's actually in front of Jupiter. I don't think it's behind, but we'll check that in a little bit. So the moon is still there, we just can't see it right now. If I bring up the gain a little bit more, we might be able to see, yeah, we're kind of losing Saturn's largest moon, Titan, there. So we've got a lot, there are actually a lot more moons there that we're not seeing. Jupiter now has a total of 79 moons. We have the 4 large ones there that we're able to see, again, about the size of our moon. But the rest of them are much, much smaller. In fact, they were typically not discovered until we had a probe go in orbit around these planets. And being much closer, they were able to see these smaller, fainter objects. But in 1892, Edward Emerson Barnard actually discovered the 5th moon of Jupiter. It's called Amalthea. He discovered that when he was out in California using a 36-inch telescope. So Galileo Galilei discovered these other 4 moons in 1610. And, we're really starting to lose them now. But so Galileo discovered those 4 moons in 1610 using a very small telescope. You can even see them with binoculars, especially if you steady yourself. But in September of 1892, Edward Emerson Barnard discovered the 5th moon, and he actually spotted it by eye. It takes a very large telescope and a very keen eye to be able to see it. But he discovered the 5th one, and it would be the last time that anybody would just look into a telescope and spot a new moon around one of these planets. All the rest were taken through long exposure photographs or by sending a probe to those planets. So Jupiter still is in the lead with the number of moons. Saturn's not that far behind. Uranus and Neptune are quite a ways behind there. But in the coming years, if we send more probes to these other planets, then we'll probably discover even more of those moons. So yeah, we are starting to really get down into the trees here with Jupiter and Saturn. So I really had to bring up the exposure just to start to see some of the fainter moons there. But you can see how really fuzzy they're starting to get now. So one other thing to remind you about Jupiter and Saturn, because these are planets and they're all orbiting around the sun, every year we're going to see them in a different position in our sky. It's not going to be a drastic position, but we'll see that they've moved a little bit through the constellations. So a lot of people ask, well, what's the best time of year to see one of these planets? And there's really no answer for that because these planets are constantly moving. Right now, Jupiter and Saturn are nice fall objects, but give it a few years and Jupiter will instead be a very nice springtime object. So you just kind of have to use a program like Stellarium or go to the internet and get a table of data to figure out exactly where these planets will be at different times. But one of the nice things about the planets out to Saturn anyway is that you can see them naked eye. So that's how they were known since antiquity, even though we had no idea they were planets until Galileo first observed Jupiter back in 1610. We just knew that there were these strange objects that moved among the stars, so they were called wandering stars, a Latin term of which is a planet. The caveat to that is Mercury, because it never strays too far from the sun. It's not super reflective. It's also very small. It's kind of hard to spot, but there are times called the greatest elongations where it gets basically at its maximum distance from the sun from our viewpoint, and you can see it in late evening or in the early morning. So, well, let's see, it's 6:05, and we're still getting farther down into the trees. So I say, let's go back to the one suggestion that we had. I'm going to pull up a program, and I'll do a new screen share here in just a moment. All right, so let me try to do a new share. Okay. So if my screen sharing is working right, then you should see a simulation of the night sky. So this is not true sky right now, or I shouldn't say it's not a view of the sky right now, but this is a computer simulated view of our night sky. So this is the free program Stellarium that I had mentioned earlier. You can go to stellarium.org and download it. There's even a web-based version. Doesn't have as many features, but doesn't require installing anything. So I'd recommend that as well. But I've got it set for Nashville and our current time. And so you can see right over here, I'm going to drag the screen around. We've got Jupiter and Saturn setting over in the southwest. So I'm going to select one of those guys, and I'm going to zoom in. So just ignore the little red lines. That's saying that I've selected these planets. Okay. All righty, so here I'm going to change the orientation of the view. There we go. All right, I'm going to deselect. So here are the three large moons we were just seeing. Here's Saturn up here, and towards the beginning of the program, we could see its largest moon, Titan. So it turns out that that fourth moon that we were looking at earlier, Ganymede, it was actually going behind Jupiter there. So if I were to go back 1 hour of time, let me recenter. So this is what we were looking at the very beginning of the program. We got a little bit of sky glow there. There we could see Ganymede. So, so these four moons, again, these are the four large moons that Galileo discovered. Now, one of the other features we haven't really mentioned is Jupiter's Great Red Spot. So there it is there. That is a very large storm on Jupiter that's been observed for several hundred years. It's basically like a very large hurricane on the planet Jupiter. In fact, it's larger than the Earth. Jupiter, from one side to the other, is about 11 times the diameter of the Earth. So this hurricane, which we have seen shrinking over the past few decades, was originally large enough to where it could hold about 2 to 3 Earths in it. But it's gradually shrinking down. Now, hurricanes on the Earth may only last for a few weeks, maybe upwards of a month if they're lucky. But this one, again, has been going on for at least several hundred years. And the reason for that is that Jupiter and Saturn, for that matter, are still shrinking down by a tiny amount each year, basically on the order of a couple millimeters per year. But that causes the interior of these planets to stay hot, and they actually give off more heat than they radiate from the sun. So as a result of that, these storms, just like storms on the Earth, the hurricanes, they need a power source. They form out over these areas of hot water over in the oceans, and they gain energy from that. But once they get over cold land, those hurricanes just fall apart because they don't have that fuel source anymore. But on Jupiter, we have the same thing, except that Jupiter doesn't have a solid surface. So as a result of that, that fuel source, that interior heat that's being generated, is never quenched. It's constantly there to fuel these storms. So all of these little white dots that you see, like these little white dots here, those are all individual storms on Jupiter as well. Let's see, we can go into a lot of other details, but I just want to point out this one little moon right here. So this is Io, the large, or not the largest, but one of the large moons of Jupiter. It is the most volcanically active body in the entire solar system. And that's because it's the closest in of those four large moons. The tidal forces of Jupiter are so strong on this moon that this moon is literally stretched and squished as it's orbiting the planet. So that creates a lot of friction in the inside of that moon, keeps it very hot, keeps those volcanoes going. Okay. Now I'm going to move out and just mention one other object here. So zoom out just a bit here. We're going to go back up to Saturn right here. And I'm going to center in on Saturn. And I'm going to remove the atmosphere to where we can see it just a little bit better. All right. So here, all these labels here, these are labeling all of the different moons that are being shown here. So Saturn has a large number of moons as well, but a lot of these are very, very difficult to see. I think the final thing we'll mention tonight, if you remember before, I mentioned that Saturn's rings will go edge on every now and then. So what we can do with this program, we can increment time. Let me see if I can get that to come up here. Oh, it's over here. There it is. So it's a fun program because you can go through time. So I'm going to go to this time next year. So notice that. I'm going to go back to this year. Now watch when I go to 2021, watch Saturn's rings. So they look like they're a little bit less tilted. In fact, the whole planet looks a little bit less tilted. I go another year, even less tilt. 2023, even less tilt. 24. And now we're getting into 2025. So now the rings are getting to where they're almost edge on to us. So Saturn's not actually like going back and forth and wobbling back and forth. It's that Saturn is tilted over on its axis, very similar to the amount that Earth is tilted. And as it's orbiting the sun, it takes about 30 years to go around the sun. But every year that we see it at a little bit different perspective. So it looks like it's tilted a little bit differently, but it's basically, we're just looking at it from a different, we're looking at it from a different angle. And so every 15 years or so, we see those rings go edge on. You'll notice that during those years, Saturn doesn't look quite as bright in the sky because those rings are very reflective. They're made of ice and they're very, very reflective. And so when the rings go edge on, they don't reflect as much light to us. And so Saturn as a whole appears pretty dim. Okay. All righty, well, yeah, we are now starting to really get down into the trees. So you'll start to see, it looks like Jupiter and Saturn are getting these halos, and that's actually an effect of us looking through those trees. So I think we're probably going to have to, unfortunately, end our view. I wish they were up higher in the sky so we could look at them longer tonight. But I think it is, I'm so glad that we all had this opportunity together tonight to actually see this. So even though the main conjunction was tonight, I highly encourage you to go out over the next few nights, continue watching these planets, watch them now get just a little bit farther and farther apart. Because they're so close together in our sky right now, every little bit they move will be much more easily detectable by the eye. So tomorrow night, you'll definitely see that they're farther apart, the night after a little bit farther apart. Then after a couple of weeks or so, and they're still inching farther and farther apart, you may not notice it as much because now they've gotten substantially farther apart. So again, we'll have another of these conjunctions in 20 years. They just won't, these two planets won't be this close together. So again, the next conjunction where we have them this close together won't be for another 60 years, March 15th, 2080. So hope everyone can stick around for that one as well. I plan on being there for that one. Hopefully I'll make it. But again, I want to thank everybody for joining us tonight. This was a lot of fun. I wish we could have done something more in person, but hey, we got to send this out to everybody, especially for those that were unfortunately in clouds or rain tonight. And it's a great way for us all to interact there. So on behalf of Dyer Observatory and Vanderbilt University, thank you so much for joining us tonight. We will continue doing virtual programming as we start getting into the new year. So definitely go to our homepage, dyer.vanderbilt.edu, and look for updates there. We'll be doing some virtual star parties. We'll be doing some lectures. And if we have some other interesting events pop up, then we'll definitely try to do something for there. And we'll also post any updates when we start getting back to a more normal routine where we can start having people up here But unfortunately, right now, we're going to have to stay virtual for a little while. But again, we'll be posting updates to our homepage. So thank you again for joining us. I had a blast tonight. I'm so glad we all got to spend this time together. And I hope everybody has a great holiday season. Please stay safe out there. So, thank you and good night.